an honor to have us a chance to give a lecture about the creating cohort definitions, which is the most important session of today. So, good I might. I'd like to really say this to other people. So, yeah, I do have plenty time. So this session will be last 1.5 hours, and we do have a lunch time for an hour. So you do have plenty of time to explore the Atlas to create your own studies building blocks. So I've deployed 3 different Atlas demos, and who wanna pick one? You do have 3 different choices, and I'd like to the choice should be distributed between you guys. So how many of you guys want to pick server 1? Raise your hands. It has to be about 20. Okay, right. Yeah, right now you do use server 1. Do you want, which one wants to use server 2? Server 2 is the best. Right. Okay, so you do use server 2. And the rest one should use server 3. How many of you need to use server 3? I think the distribution is even, but if you have a problem with using server 1, 2, or 3, then you can use just server 0. So please make sure that you can connect to this website, this Atlas demo. So I just typed the numbers with the periods, and you can connect to the Atlas just like this. And if it's your first time, you have to accept the license policy of the university, which does not harm you. So just click the accept. And there is a YouTube video to how you can deploy this Atlas demo on your GCP. So it's really easy to deploy this Atlas with the demo data on GCP. So if you find them, so let me show that. So if you type the GCP OMOPCDM in the Google, then it allows you to link to this blog, and then you can go to the Atlas on GCP. And if you, I'm sorry that it's in Korean, but if you click this blue button, then you can deploy the Atlas with the demo data, and there is how much you need to pay if you just continue to deploy the Atlas on your GCP instance. Currently it costs $50 per month. So if you continue to deploy this system on GCP per month during a month, you have to pay $50. It depends on what kind of the instances you use. If you want to use some, with better performance, with better CPUs, then it costs more. But it's not. I think it's really reasonable cost. So, is there anybody who have a problem with connecting to this instance? Okay, I think all of you have connected to the server. So yesterday we have a lecture from Jack about this SS challenge. We do have to study designs, characterization, and estimation. So we want to know the rate of aortic aneurysm or dissection after initiation of fluoroquinolone, and we'd like to compare the risk of aortic aneurysm or dissection between the fluoroquinolone compared with other antibiotics. These are the 2 different outcomes. So we defined the aortic aneurysm and dissection. So today's agenda is, first of all, I want you to know about the cohort in OHDSI, and then we will create cohorts for users of fluoroquinolone with urinary tract infection, and then we create the cohort for aortic aneurysm and aortic dissection in Atlas. That's 2 tasks we are we're going to do during this session. So this is the caricature of the patient journey. So in our EMR or the claim data or our registry data, we have the records from the patients about their conditions, which means diagnosis and drugs, procedures, and measurements like this. Actually, our databases or each observation database is just a compilation of patient journeys. So there is a patient 1 and 2 or 3 and 4. So our database is just a stack of this patient journey, and our task of today is to define how we can define the patient journey and how we can identify the right patients for during the right time. So again, the cohorts is the common building block of all observation analysis in OHDSI. So if you want to do some characterized baselines, if you want to produce some baseline summary of exposures, then you need a cohort. So it's with the person with the defined start and the end date. If you have another cohort, then you can compare the characteristics of these two cohorts. And then if you have an outcome cohort, then you can identify the baseline summary of outcome, or you can calculate the incidence of outcome among these cohorts. And you can compare the incidence between the target and comparator. And you can, you can conduct a comparative effectiveness or safety study. So you can calculate the, hazard ratio or odds ratio between the target and comparator cohort in terms of outcome cohort. And you can make some artificial intelligence system to predict outcome, which one will have an outcome among the patient in target cohorts. So we usually call this as a phenotyping. So what is the phenotyping? The phenotype is a specification of an observable, potentially changing states of an organism. The term phenotype can be applied to patient characteristics inferred from EHR data or claims data. So the goal is to draw a conclusion about the target concept based on the raw EMR or EHR claims data or other clinical relevant data. There are two approaches to phenotyping. One is the probabilistic phenotyping, which means you can, the definition of diabetes is usually, we have some definition of diabetes, but sometimes, a person can have a 70% probability of diabetes. Some people have really, 99% of probability to have diabetes. So it's, even though we have clear cut for the diabetes, but actually the disease is not just binary thing. It can be continuous thing, and by we can make some probability of having some conditions. We do have that module on this ecosystem, but today we will use a role-based phenotyping, which is much familiar to us by using. But if you want to make some role-based phenotyping, usually you have to know how to write a SQL code or R code. But in this class, you will use Atlas, which provides a graphic user interface. So you don't need to know about how to write R code or SQL code. You just you will see how you can do this. Again, data in the database is something like Lego bricks for phenotyping. So we do have many bricks to make some structure. We do have conditions, drugs, procedures, measurement, observation, and visits. All of this data from different domains we can use these bricks for our phenotyping. So there are actually cohorts is really important thing in the epidemiology, but in OHDSI, just let me say, just in OHDSI, we define cohort as a subset of patients who satisfied one or more including criteria for a duration of time. Cohort era means a continuous period during which a person has satisfied a cohort inclusion criteria. So in OHDSI, cohorts has a duration or era. So we every cohort has to have a start date and end date. So you have to keep in mind that there is an error in cohorts. And the cohort definition is a specification of how we can identify of a cohort. So one person can belong to multiple cohorts. The person can belong to target, a computer, or outcome cohort simultaneously. It's possible. One person can belong to same cohorts at multiple different time periods, but one person cannot belong to the same cohort multiple times during the same period of time. So I mean that a person can be there is an error in the cohorts. So one person can belong to the cohorts during this, like from January to February, and the person can be belong to the cohort during March to May. It's possible, but it can he or she cannot belong to the one cohort during the overlap time period. It means that if a person belong to the cohort during from the January to March, the person cannot belong to the cohort from February through April because there is overlap of time. We do not allow the overlap of time duration in the same cohorts of same person. And one cohort may have 0 or more members. So it's kind of an anatomy of a cohort definition. It's really important. So again, there is an error. So from the entry, it's not easy to see. So every cohort have an entry event. So there is an entry or index date, and there is an exit. Again, we do have there is an error in the cohort from the start and the end. So it must be started, it must be ended too. In OMOP CDM, there is an observation period table which defines the observable period of a person or subjects, and the observation period, start of the observation period or the end of the observation period, depends on the each person. Each person can register, can be registered to the claim or start the visit on hospital as he or she can be recorded in the EHR. It can be a sort of the observation period, and the patients can die, or the patients can just stop to be registered in the claim or insurance, or the he or she does not go to the hospital anymore. So that will be the end of the observation period. So even though the cohort entry events and exit are dependent on the cohort definition, but the observation period is dependent on each person. And we will have inclusion criteria. There is no exclusion criteria in our cohort definition, so we only have inclusion criteria. And I will show you how you can use inclusion criteria as an exclusion criteria. So there is a temporal logic. Every inclusion criteria has to have a temporal logic. So again, if you want to define the cohorts in ATLAS, you have some questions. So what is the initial event defining cohort entry? That is the most important question. So you have to have these questions, and then what inclusion criteria are applied to the initial events. What defines a person's cohort exit? Again, there should be an exit criteria. So the started cohort should be ended too. And how should events be combined into cohort errors? So what is the initial events definitions? So the initial events, again, is the most important thing in the defining cohorts, and this is then events are recorded timestamp observation for persons during such as drug exposures, conditions, procedures, measurements, and visits. So when the event, the date of the event will be the date of starting point of this cohort. So that's why it's important. Initial events can be defined by a domain concept set and any domain specific attributed. And So when you define the initial events, you have to define existence of any observation in any domain. You can define this as a kind of the visit, or inpatient visit, outpatient visit, or ER visit, or you can define this as a kind of the observation recorded, or you can make some, you can use the drug exposure or procedures or some diagnosis, but you do not define by absence of an observation. So we usually not recommend to use a control group without any anchoring events. So we do not recommend that define the cohorts by age year of birth, because it we are cautious about making some bias by using non-observations, using non-observation as a control. And then there is an inclusion criteria after the initial events. So what is the inclusion criteria? It's kind of the additional criteria. And then when the cohorts satisfying the inclusion criteria beyond the initial event is a qualifying cohort, as it's defined as all persons who have on the initial event and satisfy all qualifying inclusion criteria. Just like the initial events, each inclusion criteria can be defined by domain concept sets and domain-specific attributes with temporal logic relative to initial events. I will show you later. And each qualifying inclusion criteria can be evaluated to determine the impact of the criteria and the attrition of persons from the initial events, initial cohort. So you need to specify all criteria as inclusion criteria to avoid confusion of Boolean logic around inclusion versus exclusion. Again, there is no exclusion criteria in OHDSI, but you can use inclusion criteria for exclude something. And you need to use information on or before index date. We do not recommend to use the information after the index event, usually. And please don't assume some temporal logic, but always provide a relative time window to evaluate criteria. I will show you later again. And lastly, we have to define the person cohort exit criteria. Cohort exit signifies when a person no longer qualified for cohort membership. And cohort exit can be defined in multiple ways, just like the easiest way is just define this as an end of observation period. Or you can define this as a fixed time interval relative to initial event. Or you can use you can define this as a last event in a sequence of related observations, such as the end of the continuous drug exposure. You can define the exit as a end of the certain continuous exposure too. So you need to specify a cohort exit, even if you are mostly you are not intending to use it for your analytic use case, but the exit criteria should be defined in for all cohorts. And please don't confuse censoring for analytic purpose with cohort definitions, such as censoring at time of outcome. So the cohort component cohorts can be defined using domains, concept sets, domain-specific attributes, and temporal logic relative to initial events. And there is concept set. Concept set is a logical expression to represent a list of concepts in the OHDSI vocabulary encompassing a clinical entity of interest. It's kind of it's just a list of the concepts, which is the codes in OMA vocabulary. We say that, such as I-21, when I-21 means that kind of a heart failure or myocardial infarction in ICD-10 code, that we call it this as a concept. So there we call concept as a code, medical code. So concept set can be thought of as an standardized computer executable equivalent of a code list, often used in observational studies. So you can define the concept sets And by using concept search, you can define the initial event, inclusion criteria, and exit strategy. And when we define the cohorts, and then you can modify the concept set. And after diagnostics of cohorts, you can modify the definition logic or your concept sets. There are many. Most of the audit studies are we make everything open public from the audit studies, and there are many examples of audit cohorts in GitHub of OHDSI. So we're gonna create cohorts for new users, not new users, users of fluoroquinolone with recent UTI in ATLAS, which Jack and our team have to create for our SOS challenge. So let me dissect the anatomy of cohort definition of this fluoroquinolone thing. So first of all, the entry event should be fluoroquinolone use without any doubt. And we want to add inclusion criteria that the patients have to have UTI within 30 days before and after exposure of fluoroquinolone. And we need to make what? We need to define something else too. Is it? Yeah, it's exit criteria. You have to define exit criteria. And we want to define end date of the fluoroquinolone exposure as an exit criteria of this cohort. So let us go to the ATLAS again. Oh, I didn't know that. Yeah, you cannot see my. Right. I thought it's just mirrored. I'm sorry. Yep. Then you did not see this YouTube. No, we saw YouTube. Okay. Great. So then, okay. So again, I think you are in this ATLAS page, right? If you have any problem, please raise your hands, and my students can help you. All right. 좀 도와주세요.
So for right now, Chan, do you want people to
Right.
along as you're doing this?
Right.
Okay. So everybody's going to be doing this hands-on while Chan walks through.
So yeah, if you have any problem to see this web page, please raise your hands. You can see this page, right? Okay. You can explore the data sources. It is a simple data with 100,000 patients in this. It's kind of a synthetic patients data, so there is no issue about the privacy because it's synthetic. In the dashboard, it's dashboard.
On the left-hand side, you'll see options, and then click data sources.
So, and you can see how many people in here and how many the distribution of gender and their ages, since it is synthetic data from the Medicare. So that's why the patients, most patients is older than 65. You can see many other domains. You can explore many other domains in this database, such as condition, which means diagnosis. Let me see that how many patients has some aortic aneurysm in this database. And if it is too slow, I can deploy more instances of ATLAS, please. So please let me know. So in this cohort occurrence report, you can see the distribution of the disease, and the bigger box means that the higher incidence or prevalence of this disease. And what is that? The darker means that the patients have multiple conditions or multiple diagnoses. Yeah, it's a little bit slow. So, and if you go to table, you can see the prevalence of each diagnosis or conditions in this database. So let me type the aortic aneurysm. So there is a thoracoabdominal aortic aneurysms. The patient, 542 patients have this diagnosis or conditions. So you can see the prevalence by month. It's really interesting that most of the patients have this diagnosis in outpatient setting rather than inpatient setting. And median age of first occurrence of this diagnosis is 70 in males. So you can explore the data, each domain like this. Let me show another example, such as drug exposure. Since we'd like to see some identified patient with fluoroquinolone, I'd like to see how many patients have the fluoroquinolone. One of the most prevalent drug in the fluoroquinolone is ciprofloxacin. So I'd like to see how many ciprofloxacin in this database. So this is the house spell ciprofloxacin. And there are many different types, different drugs for ciprofloxacin because of their, some of them is in oral tablet or some of them in oral suspension with different dosage.
Has this data been harmonized for standard vocabulary?
Right, right. Yeah, it's being mapped to the OMOP common data model with OMOP standard vocabulary, so you can navigate this. So you can see that ciprofloxacin 500 milligram oral tablet is one of the most prevalent ciprofloxacin used in these patients, in these databases. And about 8% patients have had a history using ciprofloxacin in this database. So because, again, most patients are older than 65, so that's why I think most of them used ciprofloxacin. And I believe since UTI is really more prevalent in women than men, so ciprofloxacin maybe can be used more female than males.
Sorry, but these are not RX norm concept writings, right?
No, it's yes, it's RX norm. Right. RX norm concept has several classes and the RX norm, so it's an RX norm. But the ingredient of these RX norm, different RX norm expressions, we do have the same ingredient, ciprofloxacin. So RX norm has some very complex hierarchy and relationship, but you can find some the descendants each RX norms concepts by using the ingredient. Yeah. Most people use ciprofloxacin just once in this database. There are many fascinating functions in ATLAS, but unfortunately, we don't have enough time to explore all functions in ATLAS. So again, I'd like to focus on the most important part, is defining cohorts. So you have to follow me from now on.
Can you please also spell out which option
All right. Okay. 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 So I become nervous when I have to speak English. So please let me know if I'm doing something awkward or if you have any questions. So now you have to focus. Uh, so in the Atlas, in the left side menu, you have to click the chord definitions. And then we'll make a chord. So click the new chord. No, it's slow. Yeah. And it is too slow. Please let me know that I can deploy more instances. And I recommend you to make a prefix with your name. Since I'm Sengchan Yu, so my prefix will be SCYOU. Since many of you will have make chords in the same instances, you will be so confused to identify your own chord definition. The first one we want to make identify fluoroquinolone users with urinary tract infection. So. Yeah, let's see the backbone. So you can see entry events. You can see entry event. You can see inclusion criteria, and you can see the chord exit. You have to define all of these threes in defining chords. So again, the most important thing is defining entry event, because the entry event defines your initial index date of your chord. So that is the most important part. And what should be our entry event? Right. So we want to define entry event as exposure to fluoroquinolone. So there, if you click this Add Initial Event button on the right side, then you can see you can use diverse domains to define the entry event. You can use condition era, death, even death, drug exposure, measurement, observation period, period, or visit. So we are gonna use drug exposure. Drug exposure. Which drug? Fluoroquinolone. But so if you want to use fluoroquinolone as our one of the module in definition, then we need to define what is fluoroquinolone. It's really it takes really times to define identify all of the fluoroquinolone, because fluoroquinolone has really many different drugs. So I made a concept set in your instances. You can find fluoroquinolone systematic with the prefix of SOS. Could you find, so again, any drug, click the arrow and click the import concept set. And there is a pre-made concept sets for you, and there is a SOS fluoroquinolone systemic. So let me just navigate what kind of drugs are included in this fluoroquinolone systematic. You don't need to follow the steps. So you can see that all of the 10,000 drugs are included in this concept. How did we identify 10,000 systematic fluoroquinolone? You can see we find about 50 each fluoroquinolone or each ingredient, such as trovafloxacin or temafloxacin, spironolactone, plurifloxacin. Since this study is aimed to have conduct globally, so if you do not have in Australia, if you do not have the trovafloxacin, which is Korea does not have to either, spironolactone, you have to include the quinolones, which can be used in the other side of Europe or in the other side of Asia. So that's why we have many different fluoroquinolone, which is not unfamiliar ingredients. And actually, we want to exclude the otic solutions or ophthalmic solutions since we are targeting the systematic use of fluoroquinolone. That's why we identify the otic solutions or ophthalmic solutions fluoroquinolone, and we exclude them. So we include all of the descendants of this each ingredient of fluoroquinolone, and then we exclude some of the otic solutions or ophthalmic solutions to guarantee that we only use the systematic fluoroquinolone in this study. As a result, we included more than 10,000 concepts, such as levofloxacin, and you can see that what is the most prevalent drug in this concept set. So again, ciprofloxacin is the one of the most prevalent ingredient. It means record count and the descendant record count. So record count means that how many times these drugs are recorded in this database. And this descendant record count means that how many descendants of this concept are recorded in this database. So since ciprofloxacin ingredient, the descendants of this ciprofloxacin include the ciprofloxacin oral tablets. That's why it is the most prevalent drugs. And you can see the oprofloxacin here too. So we define the initial events. And we have another inclusion criteria in our course. What was it? What is the inclusion criteria, additional criteria? Right. We want to define the indication of this drug as a UTI. So we're gonna use add a criteria by click the green button, new inclusion criteria here. So our additional criteria is urinary tract infection during 3 days before or after fluoroquinolone use. Again, you need to click the Add Criteria button, and then there are many different domains. Which domains should we use? It's diagnosis. Condition, right. So we are going to use condition occurrence domain here. Yeah, condition occurrence domain here. Again, we have to define the urinary tract infection. And again, you can import the urinary tract infection, predefine the concept that, so there will be SOS urinary tract infection when you click the import concept set. And anytime you have a problem, please raise your hands. Can see. And every additional criteria needs to have a temporal logic relative to the index event. So our index event was the use of the fluoroquinolone, and then there is a additional temporal logic about the UTI. So when the UTI should occur in these patients relative to the index date, we want to make this, we want the patient have the UTI between 30 days before the fluoroquinolone use and the 30 days after the fluoroquinolone use. So that's why I define the temporal logic like this. Like this, 30 days before, 30 days after the event date. So it's relative temporal logic. We do not have the absolute, temporal logic here. It should be the relative. So that's why the index, the entry event is important. Lastly, lastly, we have to define the exit criteria of cohort. Again, the easiest thing is just we can define the exit as at the end of the observation period. It can be death of the patients, or it can be just last day of the patients visit the hospital, or that it's the last day covered by the insurance. It depends on your database. Or you can make some fixed duration relative to the index date. So if you want to make the course just 30 days course, then you can make this as a from the start. You can observe until the 30 days after the index date. Mostly, I use this criteria end of the continuous drug exposure. So if we our cohort is users of fluoroquinolone, and sometimes we want to observe the patients until the end of the drug exposure. So let me show. Yeah. So first of all, you need to select the drug you are interested in for the continuous observation. In this case, it's going to be a fluoroquinolone, of course. And there is persistence window. So sometimes in real world setting, if you prescribe the drug during for 30 days, but patients sometimes did not come right after the 30 days. He or she can visit the hospital after those 21 days or after 45 days, because usually we do not take a pill as doctor says. Sometimes we just skip to take a pill. So we do have some rest some days to take drugs. So persistency is how long will you allow about the gaps of these drugs. So if you want to allow like 7 days between the gaps of the drug exposure, then it will make some continuous drug exposure by your definition of the persistence window. So in most pharmacoepidemiology study, we use just 30 days of persistence window, but sometimes because it's on your choice, since it is antibiotics, the 30 days of gap can be too much, too long, or you can just can allow 30 days gaps of the continuous exposure. Again, it's on your choice. The surveillance window is the extra days after the drug exposure. At the end of the drug exposure, continuous drug exposure, you can add more data, more date or more days to observe. So you can add some, extra days after the continuous drug exposure. Since sometimes the drug, adverse events can occur after, several days after the drug exposure. That's why you can add some surveillance window more. I will not here. So that's gonna be our cohort, but you can also define the censoring events. So if there is some event, then you can censor the patients in this cohort, such as we want to compare the fluoroquinolone and cephalosporin or or other antibiotics. So you can just add some censoring event about the exposure to the opposite drugs, like cephalosporin or methotrexate, trimethoprim in this case. So, but I did not make some predefined the drugs for censoring, so I will not make this criteria. But you can make some censoring events criteria too. And you have to save it. There is a save button on the top. So there is a save button again. I believe that there are many, I think. So yeah, there are many courses now. And then you can see what you did. This is the human readable definitions, what you did, what you make. So in the export tab, you can see the text, you can see the human readable text in the text view. And actually, it creates a SQL code to define your cohorts. So that's the code to define your own cohorts. And actually, you can execute this cohort definition against the database. So in the generation tab, you can generate this cohort. In the generation tab, click the generate button. Right.
So how do we know like how many? So we are generating the cohort already.
Right.
So we are already generating the cohort by pressing this button. So how many actually data sources are we using? So how can we know?
Yeah, you can link multiple databases to your Atlas instance. In our instance, the simple database is linked to this Atlas. But some in many institutions such as J&J, they do have about tens of databases are connected to the Atlas. They can just see how many patients can be created across the databases in one single Atlas instance.
Can I ask another question? I just had another question. It was related when we were talking about the exposures. Could we see before defining the exposure period, would it be possible to use like data-driven approaches to know like what is the standard duration before actually putting that into the definition?
So you mean attrition? So how many patients we can lose because of some criteria?
Yeah,
asking about the exposure length, for example.
Yeah, exactly.
So that first tab that Jan showed you was the data sources. And when you click on that, you can actually see, like, if, for example, you didn't know what's the average length of an exposure for fluoroquinolone, you could click on that and see the average. And that can guide your decision making about how to choose that.
Right. And you can see reports of your generation. In my instance, the duration of generation does not take more than 12 seconds. But if your instance is too slow, please let me know. And you can see how many patients we lost because of the additional criteria or inclusion criteria. So if you have multiple inclusion criteria, you can see how many patients you will lose because of each criteria you defined. So you can we cannot change this index event usually. So, but we can revise the inclusion criteria to retain more patients, or we don't need to retain many patients. So you can easily see how many patients you lose. And in this case, we had 27,000 events who used fluoroquinolone as an event rather than person counts. And we lose about 90% of them because of our criteria, that UTI. I don't know why that patients use fluoroquinolone other than UTI, because they are a little bit older patients, so they may have some pneumonia. The pneumonia is much more prevalent in old patients. Is there any other questions until now?
If I gotta just add to the initial question. So what you all have done here is you've created a specification for a cohort. And in this case, we're showing you how you can actually, if you had Atlas installed connected directly to your data, you could just run the cohort yourself on your data immediately and you get back results immediately. But what's also exciting here is, Chan went through it very briefly, but on that export tab, you could actually see not only a human readable description, but also a full computer executable description, which means not only have you created a specification that works in your own data, but now you can hand that definition over to anyone else in the entire OHDSI community, and they can run the exact same thing. So for example, Chan's spun up this Atlas instance, he's created a definition. He could now send me this JSON file, and me locally at J&J, I can just import it into my environment, click go. And so to your question that you asked, like, how do we know which data sources? You can use Atlas to design something, even in a demonstration environment like this, but then you have the entire community around you. Now you can share your definition with anybody else, and they can run it in their environment. And this is this whole idea of, interoperable cohort specifications allows anybody to create a definition, have an idea about it, and share it with anybody else, and they can run it. And through this interface, it's as easy as just importing the file and hitting go.
So let me show what Patrick said. We can easily export the definition of entire cohort definitions, and then we can send it to our colleagues. So if I want to, again, so I want Patrick to execute this cohort definitions and how many patients they have in J&J databases. So I need to click copy to clipboard here to copy the JSON files. Like this. This is the definition of our cohort definition in the text, and then if the Patrick received this text file through the mail, then he can just copy this cohort definition like this, and even though we are trying to import, but we have to do this in the export module, export tab. So remove the all JSON files and then copy the cohort definition I sent, and then if you click the reload button, then you can see that the cohort definition is exactly copied, and again you can generate the after saving, you can generate.
I see one light bulb has gone off. That's good. You may choose to send the file as a JSON file to somebody, or you can paste it over. So it's very common, even in very highly interactive sessions, that there may be some public Atlas instance, like on the OHDSI website, we have atlasdemo.ohdsi.org. And so if I was running locally inside of my J&J environment, and then Chan was running locally inside of the OHDSI environment, but we want to exchange something, we might just say, let's just put it out there in the public version, you grab it down and do it. So exchange can be something that literally happens in a matter of seconds. Or, emailing a file, put it up on Git, or whatever you wanted to do.
So in the main page, homepage of OHDSI, which is ohdsi.org, there is software tools section, and in the software tools tab, there is a demo atlas here too. Since it's a little bit slow, so that's why I deployed other instances for you guys on GCP. But as Patrick said, sometimes we use this demo page as a kind of the venue to share our core definitions. So after making my core definitions in my own account or my own AWS instances, then I just uploaded this core definition in the central kind of the demo atlas of OHDSI, and then Patrick can access to it, and Patrick can easily copy this. Yeah, that's in.
We got one question back here, Chen.
I have a question regarding federation. Yeah, so I understand that you can run this cohort definition against your local data set and pass this definition to someone else. But is there a kind of federation where I can run it against someone else's data set? Or is it not a proper question? I don't know. Because I saw earlier something like federation architecture. So what is federation?
Figuration. You mean figuration?
Yeah, I'll answer it briefly, Chan. So the Atlas tool is to enable you to design studies and run them locally, and then you can exchange the files. There are additional software tools in the OHDSI community that actually try to enable network studies. So there's a tool called Arachne that specifically, if you have a partnership of data sources and they all agree, you could just basically pass this same JSON and it could run on other data sources. That's all predicated on sites being willing to open up their environment to allow that type of analysis to go on. Most OHDSI network studies actually work whereby you're not sending the code and technologies doing it, but rather the individual is opting into the study and choosing to participate by running the code themselves.
Okay. So yeah. I uploaded my own study course definitions, which is a Troy project. So you can see since in this Troy project, I'm trying to replicate the previous RCTs, pivotal RCTs in observational study. So that's why there are really complex many inclusion criteria here. So you can see the art of defining cohorts by by navigating this cohort definitions.
And this is a nice example that Chan's showing here because we just showed you how to click through just to get a sense of the tool, but it is very often that the cohort definitions get very complex and the tool fully supports that. And I heard at least 3 different conversations of people interested in clinical trial feasibility. How do you identify whether or not people satisfy a clinical trial protocol? That's exactly the example that Chan's showing you here. And also the comments that were made yesterday about generalizability. So you can think about, if I do all of this restriction, you want to know how many people did we kick out because we added all the inclusion criteria. And as Chan showed with the attrition table, it tells you exactly how many people you lose at every step of the way.
And I said that there is no exclusion criteria in ATLAS. You have to use inclusion criteria to exclude something. And this is how you can use. So I use the exactly 0 count. I allow exactly 0 count of the EGFR less than 30. It means that we exclude those with the reduced renal function. And that's how we can use inclusion criteria for our exclusion criteria. Let me show you again. So again, for the fluoroquinolone systemic use, let's assume that we want to exclude those who older, younger than 20 years. I think it's possible. Okay. No. Okay. Who died? Let's see. It's really ridiculous criteria, but just let's assume that we want to exclude those who died during 30 days after the exposure. then we can use death table, death domain, and some by automatically we usually use the at least one occurrence of something, but if you want to exclude, then you can use exactly 0 counts of something, any death here, and then the relative, the temporal logic can be 0 days before and 30 days after to the index date. Or you can use 1 day after and 30 days after the index date to exclude who died, after the fluoroquinolone exposure within 30 days. So that's how you can exclude people by using inclusion criteria. Okay, so that's the one part of this exercise. Yeah, that's the first part. And the second part of this exercise is defining outcome. The outcome of our interest was the aortic aneurysm or aortic dissection, which is diagnosed in patient visit. So again, you have to come back to the core definition tab and click the new cohort. I will use my prefix with my names, and then it will be AI or AD, aortic aneurysm or aortic dissection in patients.
So you all should be creating a second cohort right now. So you've first created your target cohort, your exposure. You save that. Now we're starting a new one. Going to repeat the process to show that you're going to use the exact same tool and the same thinking, but now you're going to create your outcome cohort. So that's the one we're saving right now.
So what will our entry events? Our entry events should be the diagnosis of aortic aneurysm or dissection. So I will use condition occurrence table here. So click the add initial event button and then click the add condition occurrence here. Of course, we will import concept sets for aortic aneurysm or dissection. So there is aortic aneurysm and dissection. So you can add aortic aneurysm, and you can add again condition occurrence table again. You can add initial event for aortic dissection. Import concept sets again, and then click the dissection. So please remember that if you have multiple index events, they will be combined as OR with OR criteria, not the AND criteria. So the multiple, if you have a multiple criteria here, it will be combined as a OR with the OR criteria. You can limit only the first, the earliest event of the aortic aneurysm or dissection, or you can just let all events of diagnosis of aortic aneurysm or dissection. It depends on your clinical questions. We do have additional criteria. What is it? Inpatients, right? So I want patients to have this diagnosis inpatient visit or ER visit rather than outpatient, since the outpatient diagnosis can be false. That's why we want to make it an inpatient visit. So you have several ways to add this criteria. So you can add attributes. First first way to define the inpatient diagnosis is just to add attribute to this entry events. If you click the add attribute, you can see many different criteria you can add on this. You can define the age of occurrence, you can define whether it should be the first diagnosis, or you can add some gender criteria, or you can add some types or fidget. We can use a fidget here. And can I import? Okay, I cannot. So you can add widget occurrence. Just it's I do believe that it's no pi. What was that? Yeah. Yeah. 9201 is inpatient visit, and 262 is ER or inpatient visit, and I think that I had selected. Right. Yeah. We're not gonna use it. You will use the second way. Just see the first way. I just remember that 9203 is the emergency room visit. So we do have 3 different ER or inpatient visit, or emergency room visit. Just see this. You don't need to replicate this on your instance. This is the first way to define to add the criteria for inpatient diagnosis. But we prefer the other way. So let me just remove this criteria. We prefer to add this criteria by using just inclusion criteria. So the criteria name will be the inpatient or ER visit, and then we can add what kind of the domain we can use here. Yeah, someone says visit. So we can use visit domain here. All the visit categories have their own concept IDs. Just like 9201 means inpatient, 903 means ER visit, like that. So again, there is a predefined inpatient or ER visit here. So you can import inpatient or ER visit. When it should be occurred, compared with the the index date, I'd like to just add the date of the diagnosis. So I want the patients have inpatient or ER visit at the date of the diagnosis. So that's why I want to I make this between 0 days before and 0 days after the index date. Does it make sense?
So your index date is the date of diagnosis?
Right. We define the index date as the when the entry event occurred. So our entry event is the diagnosis of aortic aneurysm or diagnosis of aortic dissection, and I want patients have the inpatient or ER visit at the same day of the diagnosis. Finally, we have to make exit criteria too. Again, the easiest thing is just let people exit at the end of the continuous observation. but I prefer to use fixed duration. So just like 30 days.
Got a question here, Chad?
Right.
Can you just go back to the other criteria? When you're talking about the same day, so what happens if the diagnosis is recorded during an admission,
Right.
for example?
Yeah, that's a really good question. So I actually want to have some additional how you can make sure that guarantee that it is during the hospital visit. Let me show you it later, a little bit later.
Thank you.
Thanks. So I prefer to have define the court exit as a 30 days here, but it depends on your preference. It's just personal preference of mine. If I set the 30 days as a exit criteria, then it means that if the patient has another diagnosis during these 30 days, then this event will not captured in a court, because one cannot, belong to court with the overlap time period, So I think that the patients, it's really awkward that patients have the multiple aortic aneurysm diagnosis within 30 days. It doesn't make sense for me. So that's why I select 30 days, but it's on your choice again. Again, you can generate this in the Generate tab. Let me see how many people actually have this diagnosis. It's kind of rare events, but fortunately, our target patients are really old in this database, so we have plenty of people. But we found that 96% of these patients are excluded because of our criteria that inpatient visit. Since it's synthetic data, I'm not sure why it happens, but whenever we use the inpatient criteria in this against this synthetic data set, we lose many patients. It's just kind of I don't know, I don't understand how this data is synthesized. So, but I believe that there is no many inpatient visit records here. It's just the database specific things, I believe. So I hope that many of you actually follow until this. And let me dissect the rare SOS challenge we developed, as a challenge definition we developed. This is what we developed for the SOS challenge. The similar that we defined the entry event as a exposure of the drug, and we don't limit the initial events to the first one. We allowed every single events exposures to fluoroquinolone. We have including criteria of UTI 30 days before and 30 days after the index start date. We want to make sure that it is outpatient setting, because if you admitted for your UTI, then you usually conduct a CT scan, and this can find your aortic aneurysm without any symptoms. So there will be the surveillance bias because of the UTI severity. So that's why we want to make sure that the UTI treated in the outpatient setting. So that's why we exclude those who have the inpatient visit or ER visit before the 7 days of this exposure. And sometimes why we define the UTI as a beyond the exposure. So sometimes even though it is it is suspicious that these patients have the UTI, but we don't know exactly. So we just give up medication, antibiotics to treat the suspicious UTI, and if after the results of the urinary culture or just the resolving of the symptoms, then we identify that the patients had a UTI. That's why we allow the 30 days after we allow the UTI diagnosis even after the drug exposure. Here we use the define the persistence event and the criteria as the end of the continuous drug exposure with the 30 persistence windows. And what our aortic aneurysm or dissection criteria is somewhat complicated since in our concept set for aortic aneurysm, there is subdivided for condition, procedure, and observation. So let's see that. So in our aortic aneurysm definitions, there are many domains, including procedures or conditions. You can see that the patient may have the insertion of stent graft for your aortic aneurysm. We can identify the patient with aortic aneurysm with these procedures too. And we exclude those who had the aortic aneurysm or dissection before during the 1 year prior to this event. Since sometimes we use just first diagnosis of aortic aneurysm or dissection, but aortic aneurysm or dissection can recur, so that's why we did not limit this as a first diagnosis. And that's the answer to the prior question. So we want to make sure that aortic aneurysm has the, because of the during the inpatient or ER visit. So we add nested criteria. Nested criteria means that this criteria will be depends on this condition occurrence. Then again, so it has the visit occurrence relative to this cohort occurrence event. And in this case, we used fixed duration persistence to define exit as at 0. So at the day of the start, there will be exit. So just all the cohorts have just 1 day as an observable period. So this is the dissection of our cohort definitions, which is used in SOS challenge. And by using this, I said that cohorts is kind of the building blocks of every study. So by using these cohorts, you can see the characteristics of the patients, such as who did that? So you can add your cohort definitions in the characterization tab, and you can see what the baseline characteristics of these patients. Yeah, you have 1 hour during the lunch, so you can explore this atlas during the lunch. Like this, how many, 80% have patients has the urinary tract infectious disease. UTI can comprise of the many different UTIs. So that's why some 10% of them have another UTI. Like infectious disease of genitourinary systems, like that has 100% have this genitourinary system diagnosis, and cystitis is a condition. Or you can see how many, which drug they usually used. I did not see that in this case, but that's possible. Or you can make some pathways, or you can identify the incidence rate of the aortic aneurysm among these patients, by using incidence rates module. You can make a comparative effectiveness study code by using estimation tab. So in this case, this is if you heard about the last lightning talk and yesterday, then we compared the neuropsychiatric events between the LTRA users and the ICS users. And we defined our comparative effectiveness studies like here, and you can download the executable R package for this study, like this. And there is R code. No, it's not that one. Yeah. I don't know why I didn't. So it's an executable R code for your study for the comparative effectiveness study or comparative safety study. Or you can make a machine learning package by using prediction tab. Again, I don't have enough time today, and you have to enjoy your lunch. So please enjoy your lunch, and until the 1:30, you can explore the LS further. Do you have any further questions?
Thank you. Just two questions. What's the input data? Like, where do we begin? And then how do you spin up this instance? Like, does it cost money, or is it like free, or how does this work?
Patrick, could you answer to this question?
So the first question, like, where did the data come from for this? Yeah. So this specific example that you all are playing with is a demo environment that Chan stood up. It's using this synthetic data set, which is freely available from the OHDSI community. So anybody can just download this SynPuff data set if you're looking to install Atlas and just get an experience without having your own CDM. The way that the software works, though, is that it just has a pointer to wherever your OMOP CDM is. So you're pointing here to a synthetic data set, but once you have a data set that's converted to the OMOP data model, you're going to want to point your tool to your real data so that you can be doing this exact same analysis on your real data. And you can point to as many different databases as you have access to inside of the tool. The specific deployment that Chan did here, he showed that demo very briefly, but he deployed it through the Google Cloud platform. But Atlas as a web application is something that you can install in your own environment. So it's a freely available web application. If you have a web server in your environment, you can just install it there and make it available. There's a lot of different ways that the OHDSI communities try to help each other with making it easy. What Chan's showing here is a very nice example of that. You just click on a couple buttons and it's up. For your local environment, there's a Docker container, so you can just basically have a virtual machine that'll just bring in all the OHDSI tools, and that's very convenient. And there's also there's tutorials on how, if you just want to install and configure Atlas yourself, that you can just go through the steps. And Adam Black in our community did a demo where we went from scratch on a machine that had nothing to fully installed with Atlas in under 1 hour. So it's to like click through all the steps and do everything. So this web tool is available from the community, and there's multiple ways for you to deploy it in your own local environment.
Is there any other further questions? Yeah, there are many YouTube videos how to teach you how to use Atlas further. So if you are interested in more, then you can see the OHDSI YouTube channel. Okay, thanks guys.